Very good morning to one and all. Welcome back to the video lecture on data structure concepts. So today we are going to discuss a concept of infix to postfix conversion. So in the previous session we have discussed about infix notations. Infix notation is a common arithmetic and logical formula notation in which operators are written in fixed style between the operands, as we have discussed in the previous session itself. Operand, operator, operand. Such expression we will call it as a infix notation. So next we have another one type of notation is postfix notations. In postfix notations, the operators comes after the operand. For example, the infix expression a plus b will be written as ab plus in its postfix notations. Postfix is also called as reverse Polish notation. And the third category of notations we have discussed is prefix to prefix notations. In prefix notations, the operators comes before the operand. The infix expressions a plus b will be written as plus ab in its prefix notations. Prefix is also called as Polish notations. So now let us discuss how do we convert, that is the conversions from infix to postfix. Let us look at the algorithm. The algorithm, first step, scan the infix expression from left to right for tokens, operators, operands and parentheses. You need to scan complete infix expressions in which it consists of operators, operands and parentheses, and perform step 2 to till step 5 for each token in the expression. Each token in the sense, at every time it visits to a particular token. That part we call it as a token. The second step, if token is operand, then append that token to postfix expression. So try to understand the second step. If a token is operand, if the symbol is operand, then you have to append that token or operand to postfix expression. So step 3, if token is left parenthesis, push it to a stack. As the algorithm consists, if a token is left parenthesis, that parenthesis you need to push it to the stack. And the fourth step, if token is an operator, pop all the operators which are of higher or equal precedence than the incoming token and append them. See, if a symbol, while you are visiting from left to right, if you come across an operator, then it should be pop all the operators which are of higher or equal precedence, as we have discussed in the yesterday's session itself, that is in the previous video lecture, the precedence of operators. Now what you have to do, you have to pop all the operators which are of higher or equal precedence than the incoming token and append them to the output expressions. Output expression is a postfix expression. So after popping out all such operators, push the new token on stack. Now let us push the new token to the stack. So step 5, if right parenthesis is found or is encountered, pop all the operators from the stack and append them to the output string. Again you have to append them back to a postfix expression till you encounter the opening parenthesis, till you come across with the opening parenthesis. And next, immediately what you have to do, pop the left parenthesis but not append it to the output string or postfix notation. So the sixth step, when all tokens of the infix expressions have been scanned, pop all the elements from the stack and append them to the postfix notation or output string. The output string is the corresponding postfix notation. I hope you guys are getting clarity. Let us look at an example of conversion from infix to a postfix. Let the incoming infix expression be a into b plus c minus d by e. So as we have discussed in step 1, so if a stack is empty, so and we only have the infix expressions, as the expression which is given in an example itself is a infix expression. This has to be converted to a postfix expression. As you could see that a stack is an empty stack and the top is which is having a value as null value. So this is a infix expressions. Now you have to apply the algorithm. As step 1 says, the first token is operand A. So while you are scanning the infix expression, an operand A as encountered. If operand A is encountered, that is, if while scanning it has encountered an operand, then what you have to do it, you have to append it to a output, that is postfix notation. As you can see that postfix notation we have appended it. And next, immediately, till now the top is null, the stack is empty. So while we continue the scanning the expression, and next token we have encountered is operator, that is multiplication operator. Since stack is empty, top is equals to null, it is pushed into the stack. Now you could see that operator is pushed into the stack. Now top has value. And let us continue with this. Next token is we have come across with left parenthesis, that is encountered token is left parenthesis. The precedence of open parenthesis when it is to go inside the is maximum itself. So but when another operator is come to on the top of left, then its precedence is least. So as of now it is a maximum precedence. So now we are going to push it to a stack itself. Now top is incremented by 1. So you could see that. Next, continue it. Step 5. Next token B is an operand which will go to the output expression. Next token we have encountered is B, that is an operand that has to be appended to a postfix notations, as we have done it, A, B. So okay, the same, top is now 1. And next token is operator. We consider the precedence of the top element in the stack, the outgoing precedence of the open parenthesis least ref. You could see that. So plus addition gets pushed into the stack. Highest precedence is plus, so that is the reason it has placed onto a top of the stack. So next stage, next token encountered is C, which is appended to the output like this. You could see that. Next token we have come across or encountered is right parenthesis, means you need to pop all the elements from the stack and append them to the output expression till we read an opening parenthesis. See here what we have done it. We have popped all the elements till we come across